All right, I've got a data set here of numbers called normrand1.txt. Now, nowadays, most data files are usually CSV. They're comma separated. We need to have some way to separate one data item from another, but we're going to keep things real simple. We're just going to have it be like line separated, where each data point is on a new line. You can see that these are floating point numbers here. And I have quite a bit of them, actually. I have I think 3007. This is a simulation for ground temperatures in Celsius from 3007 different counties, which I think is how many counties there are in the United States. I'm looking at this right now in a Google Classroom. If you need to download it, you might need to click on these three dots and click on Open a New Window. Then you can download it, and it's fine to just download it to your downloads folder. We'll be moving it into our project folder in just a minute. So what we're going to do is we're going to do some data analysis on this data, okay? And there's lots of different ways we can do that. We're going to just kind of do it one at a time, and we're going to actually try not to put these in a list. We could load these into a list, but we're going to save that for another time. So, now that we've got that downloaded, let's go ahead and start with, actually, let's go back and look at it one more time. It's a good idea to look at your data before you start processing it, to get some sort of feel for it. So you have some sort of idea what to expect. These are, we know what these are supposed to be. If we see a value like 200, that if this is supposed to be ground temperature, which is what this is supposed to simulate, the temperature of the ground in Celsius, anything over 100 degrees would be boiling soil. So we wouldn't expect numbers like that. We do see that they are decimals. Okay, so we're going to have to deal with that. All right, so now back in our project here, Java gives us lots of different ways to handle data and process it and get results. So let's take a look at just a few of the different ways we can do that. So we're going to create a new class in a project called ground_temps. Temps, or you can call it whatever you really want to call it is fine. And I'm going to call this this here ground temps for my class. And let's just start working with it here. So for our first task today, what I'd like us to do is I would like us to find the sum of all these numbers. Okay? So that we're going to do several things, but that's our first goal. We want to find the sum of all these numbers. And we don't want to do that by ourselves, of course. We want Java to do the work for us, right? So in order to do this, we're going to be loading a data file. And the file processing is in a Java package called I/O for input output I/O. All right. So we'll need to import that today. So we're going to say java.io, and we'll be using what's called the file class. Okay. And the next thing we're going to be doing is we're going to be importing a very special error. We're going to import the file not found exception. Now, this is one of the weirdest things about Java. And it goes along with the strategy from the creators of Java. Java was created for a way for people who have great programming experience to use, but also for people with not a lot. And what they wanted to do was force us into doing good coding habits. One of the good coding habits you can have is to declare all of the types of problems your code could possibly have, so that when you write code, people know what to look out for. So, for example, if I wrote a program, and if you tried, maybe it was a program for, moving a robot around in a circle, but if you tell the robot to move in a circle continuously, it will automatically shut down. Well, I want to tell somebody that. I might call it continuous turn exception. You want people to know. And as you go through Java, you'll see when we go to our documentation, you'll see how it tells us those kind of errors that could happen. So there are certain errors where it's up to you. You can say whether or not they'll happen, or you could just let the users of your code be unpleasantly surprised. There are other exceptions. Remember, an exception stands for exceptional situation. In other words, it's an error. There are other exceptions, though, that if it's possible to happen, Java makes you declare it. They're called checked exceptions because Java checks to see if you declare them. And one of those is the file not found exception. So we'll see how that pans out. We won't be doing a lot of operations with our file. Let's go ahead though and take a look at just, briefly, let's look at the Java documentations for files. I'll just go to Java API 9 here. I think I'm using 11 actually, but 9's the first one with the search engine, and that's fine. Let's take a look at the file class together. So I want to go to java.io.file. And you can see the different ways to construct it here. We'll be using this one, the string path name. We can also, there's other ways you can create a file, but that's what we'll be using today. You'll note that we have lots of different methods we can call that we're not going to be using today. But these are different things you can do, mainly I think for when you are trying to process, send files, or write your own. So we'll be reading a file today. We could also write a file as well. So that's important. Okay. But what we'll be doing is simply scanning a file. So that's really all we have to do. So we're going to import a scanner to do that. That's in java.util. So we've already used scanners to scan user input, but today we'll be using a scanner to scan a file. We're done with all of our imports now. Let's start our class declaration. Public class ground temps. Okay. And I'm going to make a file that I'll be studying. Private file. Actually, let's not. Let's just keep everything simple right now. So I'm just going to say public public static void main string array args. This is our base entry mechanism for the program, okay? And I'm going to simply write a method here that I'll called get ground sum, or get temp sum. Okay. So if we're calling a static method, if we're calling from what I call a static context, let's make a little note here. This is a static context. Because we're inside a static method, then this needs to be a static method itself. All right. So we're going to run a static method. Later on, I'll demonstrate how we could change this to be not in a static context. But if you're going to be calling a method directly from the main has to be static. So if you're going to call a method directly from main, it needs to be static as well. All right, so the first thing I want to do is I want to create a file. And so the way we create an object in Java is we start with the class name. Its class name is file. And then, I could call it just, file with a lowercase f. That's my variable name. Or maybe I could call it temps file because they're a file full of temperatures. Or temperatures. Whatever file name you want to use is fine. I think what I'll do is I'll just call this temps for temperatures. Now, when you create a new object in Java, remember when we make an object, we're either getting it from somewhere else, like maybe getting it from a list, or we're creating a new one. We're going to be actually creating a new one. So we're going to say new. And remember, we just looked at the constructor. It's right here. File, you give it the string path name. So this path name could have a series of, these symbols here. Slashes that tell you how to move to different subdirectories. Well, what we're going to do is we're going to put this data file in our project folder for BlueJ. So whenever you don't want to change to any file directory at all, if you had it in like your C:, my documents, blah, 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 you have to do a lot of work there. But we're going to keep it real simple. So all I have to do, we're not going to switch any directory. So all I'm going to do is put in the file name. And the name of my file is norm_rand1.txt. Usually the file names have more meaningful names than this, but as you can imagine, these really are actually randomly generated because this is just a simulation. I looked into getting true data points from different sites like data.gov, things like that. I love to do sports statistics, but you have to do a little bit more formatting with it, and I didn't want to go there, so I figured I'll just make my own. All right. So we've got a file. We're now going to scan that file. So let's make a scanner. And I think I'll just call this scanner. So it's a type scanner with a capital S, and I'll just call it lowercase scanner. And remember, we're making an object, so we'll say new scanner. And let's pull up the scanner class, and let's take a look at that again. And in fact, that's the class we'll be using most of the information from. So lots of different constructors there. We've used this one already, an input stream like system.in. We've already used this one. Today, we're going to be using a file. So I'll put temps in my constructor. That's the file name. Okay, now what I want to do is I want to go ahead and move that file to our project folder. So wherever you saved it, you can leave it there if you want. You can cut and paste it. Let's go ahead and copy it. I do have an error, but I want to go ahead and move the files first. So let me show you how I do that. I'm in a folder explorer here, and this is one folder where I made them. So I'm just going to copy, right click and copy on that file name, and I need to navigate to where I'm working. Who knows where you'll be working? I'm working in my Google Drive folder, in a folder called Scanner and Classes Unit. Okay, and you can see that I've got my ground temps project folder right there. And it's got the README that BlueJ makes, and then our package folder, and then of course our .java file. I'm just going to paste it right there. Okay? All right. Okay, so we have an error. I want you to look at this error. It says unreported exception. Java.io.file not found exception must be caught or declared to be thrown. What this means is that if you are scanning a file, there's a chance that that file could have a bad file name. And we need to declare that. Or we need to handle it. Let's look at how we would declare it. This is going to feel weird to you because we don't usually write stuff after these parentheses and before the curly brace, but we will this time. I want you to say throws. To throw is to cause an error. We say that we throw an exception. Throws file not found exception. And that's going to fix this error here. But notice we now have another error down here. Unreported exception. Java.io.file not found exception must be caught or declared to be thrown. So anytime you call a constructor or a method that can cause a checked exception like file not found exception, you have to either handle it or throw it. And you'll notice that, I fixed it here. I fixed the call to this constructor by having this method throw it. But now that this method throws it, this method's got a problem. So I have to put it here as well. What this will do by throwing an error up from the main method is we'll actually shut down our program. I think you can imagine that in the real world of computer science applications, if we're making a full application for users to use, if they mistype in a file name, we don't want the program to just shut down on them. We want them to say, hey, you mistyped in the file name, fix it. But if all we're doing is some data science, a lot of computer science right now is being done by people not making full applications, engineers and health professionals, etc. It's okay. We'll just make the file shut down and we'll fix it that we made a mistake. Okay. So I do want to go ahead and actually run this program one time just to see that everything loads properly. So we'll go over here and we'll do, we could run directly this get temp sum, but I want to start with the main because that's what's usually your entry point for a program. And as you can see, nothing happened, right? That's because there's no errors, and that's good. We haven't done anything yet. All right, let's now take a look and see what if I had forgotten that one that was in the file name. Let's go ahead and delete it and see what happens. I'll compile it. And I'll run my main. And we get this error. Java.io.file not found exception. normran.txt. The system cannot find the file specified in Java.io file input stream. So it loaded a file of that name, but that file does not it does not exist. Now we could write to it if we were creating a new file to write on, but we're supposed to be reading a file, so no, that's not going to work. Which is exactly what should happen. Shuts down the program, says, hey, file not found exception occurred. All right, let's go back and fix it. Okay. Now, we could simply print the data if we wanted to see that. So let's go ahead and do that. We'll say system.out.print line. Now, what kind of things can we use with a scanner? Well, you can see that we could do, we can say has next. We can say next. Then we have all these different types of next. We could use next line, but we can use next int, next double. Let's use next double because we're scanning floating point numbers. So I'm going to say next double. Oh, but how do I call a method not in the class I'm working in? This method is in the scanner class. I have to call it on an instance of the scanner. So my scanner instance is named scanner. So I'll say scanner.nextDouble. So this scanner.nextDouble should scan a number and return it. So let's give it a try. And we'll run the method. And that's what I got as a result. If I go back and look here at this program, you'll notice that is the first number, right? Okay, so what I want to do next is I want to print more than just that first number. So what next double will do is we'll keep printing each number separated by either a space or a new line. There is an issue with the cursor not moving to the next line, but we don't need to worry about that here. As long as all we're calling is next double over and over again, it should be fine. So I'm going to do, there's several ways we could do this. We could do a for loop, because I know that there have to be 3,007 data items. I think that's kind of yucky, though, because, where is that number coming from? We could make a variable like a public static final constant. That might be better. We could do a while true loop, which will just go forever, right? The problem here is that what's going to happen is that we're going to reach the end of our file and get an error. But I want to see that error right quick. So let's run that. So you can see that it's going through all of my data sets and printing them. One of the things here is that you could have unlimited buffering. You can see that I'm not actually seeing all of the numbers, though. If you wanted to be able to go scroll up to the top, you had to turn on unlimited buffering. But you'll notice that we get this error here. It says java.util.no such element exception. So let's talk about that. The next double, we talked about, saying what you can throw. Well, this can throw a no such element exception if the input is exhausted. So if the input is exhausted, then we are done with the data file. And you're trying to scan something when there's nothing else there. Well, one of the nice things that this has is the has next. So we can ask, do you have another double for me to scan? Or you can just say has next. Tells you if there's anything more to scan. So let's use that. Let's say while scanner dot has next. Okay? Then we're going to do one more thing here. We're going to say scanner dot close so that we close the scanner out when we're done. You can get away with not using this method usually, but it's a good habit. Sometimes it's absolutely necessary, so it's a good habit to get into. All right, and you can see that we've looped through all of the data without actually having any errors whatsoever. So, hooray for us. But what were we supposed to do? We were supposed to add them all up, right? So let's think about what we could do to add them all up. Let's say we make a temporary variable called total. So I'm going to say total equals 0.0. So I'm going to start at 0.0. And then I'm going to, while the scanner has next, I'm going to take total and I'm going to increase it by the next double. Okay? And then we can do this before or after we close the scanner. It doesn't matter. We're done with it. So then I'll say system.out.println total. Just a word of caution here. When you're dealing with int values, they do have about a maximum number, just a little over 2 billion. So if that's too big, maybe use doubles to count up your ints. Or if you don't like that, you can use longs, which are much bigger, but require a little bit more work to use. All right. Let's run our program. And we'll check the output. And there it is. Okay, so that's good. Now, what I want you to do is I want you to write a method called public static void. We said get earlier when we're actually just printing. You know what? It bothers me. I'm going to call this print temp sum. I should say that from the beginning. Print. Okay? We'll call this print average temp. And it'll throw a file not found exception. And now what I want you to do is I want you to practice creating a scanner to scan a file named norm_rand1 text. I don't want you to use this method. Usually we don't reinvent the wheel. I tell you to call that method. But I want you to instead do it all from the beginning, and try and hide it, try not to look at it. Okay? And I want you to create a scanner, create a file, scan the file. I want you to find the average temperature. You'll need to count up the total temperatures, but you're also going to need to keep track of how many temperatures there are. Now, when you divide things, which you'll end up doing, we need to be careful with that. If you have two int variables, when they divide, they'll have integer division. It won't be the true thing. But as long as one of them is a double, which in this case one of them will be at least, it won't be a problem. So all you need to do is total up all the values and divide how many there are, and then we'll go over our answers. One more thing, as an added challenge, please make sure you print it rounded to 2 decimal places. If you can't remember, that's okay, I'll remind you, but try your best. Okay, what I want to do is go ahead and write the code for this method. Again, it's a static method, so that's because we're going to call it from the main method, which is static. So let's create a scanner. Oh, wait, you know what? Let's create a file. New file. And the name of our file was normrand1.txt. Let's create a scanner. You could call it whatever you want. I'll just call it lowercase scanner. Give it my file to scan. And I'm going to scan through the whole file. So I'll say, well, scanner.hasNext. This is a very common thing to say. Although some data files actually have a heading that tells you how many items there are. That's pretty common in like internet stuff, which I don't really do a lot of. But when you send information from one computer to another over the internet, they actually start the transmission with how many bytes are about to come. So, it's not that uncommon to have that kind of information. But for us, we're just scanning just a data file. And let's make a couple variables first. So the first variable I'm going to make is called sum. Or maybe total, but I'll call it sum this time. And I'm going to make it a double. The next variable I'm going to make is an int called count. And I'll also start it at 0. And then the sum, we're going to increase by each double that we scan. So next double. And then I'll take the count and I'm going to increase it by 1. So I can just say count plus plus. And then we could just print this out. We could say system.out.println, the sum divided by the count. Now, but if I do that, then I won't get a very nice formatted string, right? And I want us to, for an added challenge, I want us to make this into 2 decimals. Lots of different ways I could do that. I could do string.format inside here. I want to show that by review, and then I'm going to show you another way to do that. So I can say string.format, and I'll say %.2f. So F for floating point numbers, which doubles are floating point numbers, meaning they have a decimal place that can move up and down. And 0.2 means I want 2 numbers after the decimal place. Then for every formatter, which is indicated by the percent sign, I need to have an argument here. And so I'm going to put into there sum divided by count. So this would work really well. But I wanted to share with you a shortcut that Java has. If all you're going to be doing is printing, you can use, instead of print, you can use, print F. Now this won't go to a new line, but it means print format. And then I can just give it exactly that. So that becomes just like string.format, but it's like print format. It doesn't go to a new line unless you tell it to, and the format of string for that is that right there. So now it'll go to a new line. You could also just do a blank print line. Oh, you know what? Let's add it to, let's change this call here. Let's change this. Let's call this print average temp. And we'll run that. Of course, we could call any of the methods because of BlueJ, but normally you would, if you're not inside a developer, you can only call one. So 14.87 is the average ground temperature of all the counties. All right, one more thing we're going to do is we're just going to go ahead and close our scanner. Just, I'm bad about remembering to do that, but it's good habit. Anytime you're scanning your file, it's absolutely important to close when you're writing a file. So we'll close the file. All right. So we saw how to handle that. The next assignment that I want you to do is I would like for you to actually, you know what? Before we do that, something else I want to discuss. I think it makes sense to use static methods when everything you're doing is just reading a file and running something. But if we wanted to say load the file once and for all, we would still probably reset our scanner over and over again in each method, because a scanner moves forward and it doesn't move backwards. So you've got to make a brand new scanner to start over at the beginning. Because they only move in one direction. But I do want to discuss, what if I didn't want these methods to be static? How would I have to change that? So let's go ahead and see that right quick. So let's say that I don't want these methods to be static. I want them to be instance. Well, we're used to saying, how do I call a method in, that's a static void main. How do I call a method in the class that I'm working in? We usually say, well, you just call it, right? But this is different. You have to be in the same context. You either have to be in a static context and call a static method, or a non-static context. So you'll notice that I'm going to get this error. It says non-static method cannot be referenced from a static context. So how do we get out of a static context? Well, let's take a look at that. You need to think of the main method as being outside of your class. So to call an instance method in ground temps, I need a ground temps instance. Now, I don't have a constructor for ground temps, but Java makes one for me anyway. Now I can call these methods on that instance, and you'll see that that works just fine now. Because if you're in a static context, you got to create an instance of the class. Once I'm out of that static context, I can call anything I want. Like I could say gt.run, and I could make a public void run method, and I could call from there any method I want. I'm out of a static context, so I can say print average temp. I could say print total temp, or whatever we called that, print temp sum. So once you're out of a static context, then that rule applies, that if you want to call a method in a class, just say the name of the method. But that's that added layer to it, that if it's a non-static method, you need to call it from a non-static method. Make sense? If it's a non-static method and you want to call it from a static method, you have to make an instance of the class, then call the method. Well, not have to throw the exception. Anyway, so all that was just, I hope that made a little bit of sense. Static can be really confusing for people, I know. So I just want to take everything back to the way I had it before. It just makes sense to keep all this static for now. Okay, so hope you got something out of that. Next thing I want to do is I want to go over, I want you to make another method for me. So this one's going to be public static void number below freezing. And again, we'll be doing that. So what I want you to do is I want you to print out how many temperatures are at 0 degree or 0 degrees or lower. Okay? So these are Celsius ground temperatures. There's a few that could be freezing. We could take a look at the data set and see that is indeed the case. I'm just looking over here. Let's take a look here. We can see. Pull it over here on the screen. You can see there's one right there. So I just want to know all the ones that are below 0. Technically 0 is freezing, but I want to say below freezing. So I want you to print out how many of them are below freezing. So pause the video and give it your best shot. All right, so hopefully you had some success with counting the number of temperatures that were below freezing. So again, the more you practice creating a file and a scanner, the better, because we're going to, those are your fundamentals for, data science. So file, I'll just call it file F this time. F for file is a new file, and the name of my file was normrand1.txt. Sorry for the bad file name, but there you go. Scanner SCN, I'll call it SCN equals new scanner. I like to use different names for these variables to remind you that these words here are important. It is of type scanner. It is an instance of the scanner class. You have to tell Java what your variable type is. This is me calling the constructor. But what variable identifier name I give it is totally up to me. Okay, so I'm going to say, I'm going to make a count. Okay, I'm going to say, num below. And that's going to start at 0. And I'll say while my scanner dot has next. Very common thing to do here. Notice we're using a while loop because, oops, I can't say scanner anymore. I got to say, well, I changed the name of it, right? The while loop is, tells it to go while that condition is true. So while it is true that there is more to scan, it will keep scanning. And I'm going to ask a question. I'm going to say if scan dot next double is less than 0.0, I'm going to say num below plus plus. Okay? And then I'm going to, after I'm done, I'll say system.out.println num below. And then, we'll go ahead and, if we can remember, it's a good idea to close your scanner. And there we have it. So, I'm trying to practice running things through the main so I can see how it would work outside of a development software. So we're going to run the num below freezing. Okay. Number below. Number. See if it likes that better. There we go. All right. It says there are 56 of them. 56 numbers below freezing. All right. So the next activity I want you to do, and if you want, you can, it'll be almost exactly like the scope. There's going to be a very important difference. I want you to write the method public static void print below freezing temps. So this time what I want you to do is I want you to print out any temperature that it's below freezing. Give it a try. Okay, so I'm just gonna take this right here and I'm gonna copy and paste it, and I want to show you what I call the naive solution. Okay. Now, don't be insulted when I say that. I've been plenty of times been told my solution was the naive solution. What we mean is it's the solution that people tend to give the first time they do something. And there's just certain mistakes in computer science you have to happen to everybody, okay? So let's say that we did this. We say, okay, I don't want to keep track of how many there are. Instead, I'm simply going to print them every time they are below freezing. So I'll say system.out.println next double. Compile, and let's see what happens. I'll run my main here. All right, so one of the things that you'll notice is that these are not negative numbers. So let's take a look at the data file again and see if we can figure out what's going on. So there's a negative number right there. Look at the number right below it, though, 13.73. 13.73. Let's find another negative number. This is negative 0.849. And then the number below it is that. You'll notice I did get one negative number here. Let's see if we can't find what caused that. It's going to be way down here, I think. Let's see if we can't. Well, I think I've gone too far. Yeah. I want to find it. I know it's there somewhere. 12 point. All right, so I found it here. You'll notice this negative 3.528 is here. It printed that one, but that's only because the one above it was negative. So let's talk about what's happening. Every time I say scanner.nextDouble, scn.nextDouble, every time I say that, the scanner moves forward. Okay, so let's go back and look at, let's look at that first number that it would have come across that was negative, right? Which is this one right here. Well, it's going to scan this with this line right here. This line 45 is going to detect, 46 is going to scan that number. It's going to place it right here. It's going to see, yes, that's less than or equal to 0. So now we're going to print line the next double. Well, what's the next double? The next double is 13.10. So I can't do that. What I need to do is make a variable to keep track of it, to hold it. So let's say double number scn.nextDouble. Now when I've done that, I'm able to get a value. I say, okay, let me hold on to that value because I may need to use it. Then I can say number. And if that number is less than 0.0, then I'll print that number. And that's kind of that's the trick. And there we go. Oh, this is interesting. E negative 4. That means that number is very, very close to 0, but it is definitely negative. Okay, I wonder where that one came from. Curious about that one. What is that one? The negative 9. It's in there somewhere. All right. Well, I'll tell you what. Let's go ahead and let's finish off by doing one more to drive this home. Okay. So I want you public static void print nice temps. And what I want you to do is I want you to print out all the numbers. I want you to print out all the temperatures that are between 15 and 25 degrees. Okay? Anything that's greater than 15 and less than 25. So would you go ahead and do that? And then that'll be a good place to stop.